Welcome to Legacy Learning Hub. Today we are going to look at a fundamental topic in chemistry called the structure of the atom. Now, under the structure of the atom, these are what we are going to look at: the characteristics of subatomic particles, the atomic number, and what the mass number or the Nucleon number is. And then we'll also look at what an isotope is and how to calculate the relative atomic mass. So, the proposed structure of the atom as used today is a collective work done by scientists like J.J. Thomson, Rutherford, and Chadwick. Their works discovered that the atom is made up of subatomic particles, and these subatomic particles are protons, neutrons, and electrons. Now, the structure of the atom as proposed is made of the nucleus, which contains the protons and the neutrons. And then around the nucleus are shells where the electrons orbit. So the path on which the electrons orbit is what we call the shell. So this is the structure as proposed by the works done by the various scientists. Now, moving on, we want to look at the characteristics of these subatomic particles. So taking them, we are looking at their characteristics based on the mass and the charge. So we have the particle. The first one, which is proton. The second one, neutron. And the third one, which is the electron. Now, taking the mass of these subatomic particles, they are very small to be measured, and so we compare their relative masses, so in terms of their ratio. Now, looking at the mass of proton, the mass of neutron, and then the mass of electron, by comparison, proton has a mass of 1, which is the relative mass, not the actual mass. Neutron also has a mass of 1, which is the relative mass. Now, electron, as compared to the other subatomic particles, are very small, and so the mass is very, very small. In most cases, we say it is almost zero. Almost zero. But the figure is taken as 1/1820. And this is the mass of an electron as compared to proton and the neutron. Now, when we come to the charges, the charge of proton is +1. So we say protons are positively charged. The charge of a neutron is 0. So we say the neutron is neutrally charged, or it has no charge. So we say the neutron is neutral. And then we have the electron. The electron has a charge of -1. So we say electron is negatively charged. Knowing the characteristics of the subatomic particles, there are other terms that you need to know. So the first one, which is the atomic number. So the atomic number refers to the number of protons in the nucleus of the atom. So if you take the structure of the atom, the nucleus, protons and the neutrons. We have the shell where the electrons revolve. So the number of protons in the nucleus is what is called the atomic number. Number of protons in the nucleus. Now, the sum of the protons and then the neutrons gives us the mass number. So we say the mass number is the sum of the number of protons and neutrons in the nucleus of an atom. So to find the mass, we need to add the proton and the neutrons. Now another thing you need to take note of is that the number of protons in any given atom is the same as the number of electrons in that atom. So with this information, we say that the atom is electrically neutral. So the atom is electrically neutral. This means that it has equal number of positively charged particles and negatively charged particles. So they cancel out, making the atom electrically neutral. So these are the informations you have to know, or the terms you have to know in or under the structure of the atom. Now, when you are given the mass number and the atomic number, you can use this information to find the number of neutrons in the nucleus of the atom. So let's look at an example of how to find the number of neutrons when you are given the atomic number and the mass number. So from definition, we get to know that the mass number equals atomic number plus the neutron number, or the number of neutrons. So if we take the mass of an atom, mass number of an atom to be 25 and the atomic number to be 12. How do we find the neutron number? So from the equation here, we can do change of subjects, and the neutron number equals mass number minus atomic number. So here the mass number is 25 minus the atomic number, which is 12. 25 minus 12 gives us 13. So the neutron number for this atom is 13. And this is how to find the neutron number when you are given the atomic number and the mass number. We continue with the lesson on the structure of the atom by looking at isotopes, and then specifically we look at how to calculate the relative atomic mass of a given element. So let's begin with the definition of isotope. So when we say isotopes, what are isotopes? So isotopes are elements with the same atomic number but different mass numbers. So from the structure of the atom, when we say an atomic number, what does that mean? Atomic number is the number of protons in the nucleus of an atom. And also mass number is the total number of protons and neutrons in the nucleus of an atom. So when we take an isotope, we want to refer to elements that have the same number of protons in the nucleus of an atom, but they have different number of neutrons, making their mass numbers also different. So we have some examples here. So the first one is hydrogen, the element hydrogen. Hydrogen has 3 different isotopes. So we have hydrogen with isotopic number 1, and then 2, and then the third one, which is hydrogen 3. Now for these isotopes, the first thing we see here is the same number of protons, which is referred to as the atomic number. So they all have the same atomic number. But you'd realize, or you can see, that there are different mass numbers. So this represents an isotope. Similarly, we have carbon, the element carbon. Carbon also has 3 isotopes. So the first one being carbon 12, second one being carbon 13, and then the third one being carbon 14. They all have the same number of protons, which is the same number of atomic number, but different mass numbers. So when we take the isotope, you realize that because they have the same atomic number, it means that they all have the same number of electrons. So if we take the atom, we say that the atom is electrically neutral, which means that it has the same number of protons and then electrons. So the elements of, or the isotopes of any element have the same number of electrons, which means that they have the same chemical properties. So when we take a characteristic of isotope, we say that they all have the same chemical properties because they all have the same number of electrons. So basically, this is what we call isotopes. So you have to take note, or you need to understand that for every element, there are mixtures of isotopes, as we can see with hydrogen and then carbon. Now, given the different masses, we cannot consider only one isotope of an element as the mass of that element. We need to take into conclusion all the isotopes present. And this is what brings us to what is called the relative atomic mass. We are saying the relative because we are taking into consideration the mass of all the isotopes of the elements. So we move on to look at how to calculate the relative atomic mass of an element. As earlier mentioned, every naturally occurring element is made or consists of a mixture of isotopes. So in finding the mass of an element, we need to consider the masses of these different isotopes. And considering the mass of these different isotopes brings us to what is called the relative atomic mass. So to calculate the relative atomic mass, we need to consider the mass of each isotope and the abundance of each isotope. Now the abundance here is the percentage of isotope present for any given element. So here we have an example. A naturally occurring lithium consists of 7.5% lithium 6 and 92.5% lithium 7. How do we find the relative atomic mass of lithium? Now, to find that, we need to find the sum of the product of the mass of each isotope and the abundance of each isotope. So given the formula, sigma isotopic mass times abundance, where the sigma means the sum. So to solve this question, we need to take each isotope and then find the mass. So the first one, lithium 6, it has an abundance of 7.5 and then isotopic mass of 6. So putting that in the equation, we have 6, which is isotopic mass, times abundance, which is 7.5. Now 7.5% can be written as 7.5 over 100 in a bracket plus the second isotope, which is lithium 7. So the mass is 7 times the abundance, which is 92.5 over 100. Now we add the two. You first compute what is in the first bracket. So 6 times 7.5 gives us 45.0 over 100 plus 7 times 92.5 gives us 647.5 over 100. Now, since the denominators are the same, we add the numerators. So we have 45.0 plus 647.5, and that gives us 692.5 over 100. Now 692.5 divided by 100 gives us 6.925. Now rounding to one decimal place would give us 6.9 atomic mass units, and this is our answer. Alright, so let's look at the second example. We have magnesium consisting of 78.6% magnesium 24, 10.1% magnesium 25, and 11.3% magnesium 26. Now, how do we calculate the relative atomic mass? So we use the formula, the sum of the isotopic mass times the abundance. So given the first isotope, the mass of the isotope is 24 times the abundance. So the abundance given in the question is 78.6%, which can be written as 78.6 over 100 plus, so we move to the second isotope, which has a mass of 25 times the abundance, which is 10.1%, which is 10.1 over 100, plus the third isotope, which has a mass of 26 times the abundance, which is 11.5%, which is 0.3%, which is written as 11.3 over 100. So when we work the brackets out, 24 times 78.6 gives us 1,886.4 over 100, plus working this out gives us 252.5 over 100, plus the third bracket gives us 293.8 over 100. Now because we have the denominators being the same, we'll have 100, and then we add the numerators. So adding the numerators gives us 2,432.7 over 100. 100 divided by 2,432.7 gives us 24.372. And then to one decimal place gives us 24.3 atomic mass units. And this is how to find the relative atomic mass of any given element. Now, looking at the answer, you'd realize that the relative atomic mass of the element is the value is more closely related to the isotope with the large abundance. So which means that it is isotope with mass number 24 that contributes much to the atomic mass of the element magnesium. So in calculating the relative atomic mass, your answer or the value should always be closer to the isotope with the largest abundance. So this is how to work out the relative atomic mass. We have come to the end of today's lesson on the structure of the atom. I hope that this lesson helps you better understand this fundamental concept in chemistry. In our next video, we'll be looking at drawing the electronic configuration. We'd like you to like this video, share, and then comment. If there's anything you don't understand in any topic in science, please write that in the comment section. We would also like you to subscribe to this YouTube channel and then look forward to amazing videos. Thank you.